Good day again. So let us continue our discussion by introducing the next of the basic integration procedures, which is all about pattern recognition and change of variables. So you can see from your screen a general expression of a certain integral and of course the antiderivative that is given by this expression. Now I want to talk about this integral of f of g of x, which translates to the integral of the outside function compose composite with the inside function multiplied with the derivative of the inside function. So when we say inside function, for example, I have, let's say, a function, a trigonometric function, let's say cosine of 3x. So the inside function in this case would be the 3x, which is usually the algebraic expression, and then the outside function will be this cosine function, which is the trigonometric function. This is usually the composition function that you can see whenever we integrate certain expression. And if you would be remembering the last video, there was this case in the last video wherein I think I had to discuss things about this inside and outside function, which I called them the parent function. So in this video, we'll be digging deeper into more examples for that. And just remember, if you have a function or a composition of function wherein you have an inside function, if the derivative of that inside function comes out of that certain composition of function and then is multiplied with the composition of function, meaning the outside would be the f of x or f of g of x, then we can say that the integral of that expression would simply be the antiderivative of g of x, which is just the inside function. So I think it will be best if I give you examples regarding this topic. So let's start by having the one in your handout. Okay, so this is the first example, and if you would be sticking to the general steps in solving for the integral or the antiderivative of a certain integral expression, we know that we have to inspect if this is a fading integrand, and if it's not, then we apply other properties. And in this case, it is not a fading integrand because, as you can see, you can't find any rule that will fit in this kind of expression, because basically this is a product of a trinomial and a binomial, so something like that, of course raised to a certain power. So with this, let's evaluate that using our general concept of chain rule, wherein if you would be looking at the inside function here, which in this case the inside function would be this one, that is 3x to the fifth minus 2x plus 1. So let's just call it the inside function g of x. Okay, and the outside function here is the one that makes this g of x cubed. So by that we say that f of g of x is literally this 3x to the fifth minus 2x plus 1 cubed. Now if we talk about this, let's just write it here. The outside function is the one that is where g of x is raised to the cube, and then of course the g prime x is simply the derivative of the inside function, and it should exist as if it's the exact derivative of that function. So that would be 15 x to the fourth minus 2, and that is exactly the derivative. So with that, we can rewrite this in terms of f of g of x times g prime of x, and in this case, remember, if you want to integrate this kind of expression, the only thing that we need to integrate here is the inside function, which is the g of x. So if you will be able to integrate this, of course with respect to the outside function, then and the variable of integration, then we'll be able to obtain the correct answer here. So with this, I'll be removing this first. Sorry. So I think we can proceed with this now. Integrating this, we could obtain 3x to the fifth minus 2x plus 1, and then we raise this to 3 plus 1 divided by 3 plus 1, okay, and then added with c. So this is your final answer, because it says in the rule that all you have to do is integrate the you use for, it says in the rule that you just have to integrate them with respect to the f of g of x. So with that being said, the final answer would be something like this. Okay, so if you want to check it, we can just differentiate this. So 4 will be multiplied with this whole expression and then subtracted with 1. So that's cubed. And then you take the derivative of the inside function. So that's 15x to the fourth minus 2. This is exactly the derivative. So with this is our final answer. Okay, and this is a very simple one because it is almost evident that we can see that this is the derivative of the inside function, and that is the essence of having this pattern recognition. You don't have to write several things just to identify it. You can just know it by simple inspection, because if you'd be looking here and try to differentiate at the back of your mind, then you would notice that this is exactly the derivative. So let's proceed with another one. Okay, so for the next one, let's have this one. The integral of 2 e raised to 3x divided by 1 minus e raised to 3x quantity squared dx. Now again, when we say pattern recognition, what we have to do is to mentally think of the inside function and then try to differentiate that inside function. And if it comes to a point where the derivative exists in the equation, or it is multiplied to that certain inside function, then we can perform the general concept of integration for that case. So ngayon dito, pag chinek natin, what you can see here is the inside function being at the denominator. This 1 minus e raised to 3x is actually the inside function. Okay, so yun yung nasa loob natin kasi when we try to differentiate this 1 minus e raised to 3x, the derivative is on the outside. But the thing here is that the catch ay hindi siya eksaktong ganun yung magiging sagot. But we can actually do something like multiply this to a certain number just to make it look like the exact derivative. So in that case, I'll do that. Gagawin natin yon. So this should be equal to something like what is the derivative of this 1 minus e raised to 3x? So if you know your differentiation, ang derivative ito is supposedly be negative e raised to 3x times 3. So this is supposedly the derivative. And then let's copy the rest. Okay. So with this being multiplied to 2, kasi nandun pa siya, so ilalabas ko itong 2 dito. This makes the expression something like 6 or negative 6 e raised to 3x divided by 1 minus e raised to 3x quantity squared dx. But then again, we should not change the equation. Kailangan maging same pa rin sila. So what we'll do here is that we will try to perform the inverse of what we have actually done here to change the equation. So with that being said, we can multiply this by negative 1/3, so that in a way we can cancel out 3 here and then this negative 1, so that we're left with the same expression. And then we can rewrite this in terms of something like negative 2/3, the integral of negative 3 e raised to 3x and then 1 minus e raised to 3x dx. Okay, so this can now be integrated in a way that I forgot the squared. This can now be integrated in the sense that the inside function has the derivative on its numerator, which is actually multiplied to the f of g of x itself. Okay, so with that said, the integral or the antiderivative of this expression is negative 2/3. You just have to copy this negative 2/3 and then differentiate the inside function together with its composite, so f of g of x. So that makes this 1 minus e raised to 3x or quantity squared. So that means that this is raised to negative 2 plus 1, and then you divide this by negative 2 plus 1, which gives us the final answer that is equal to 2/3, and then I think that should be 2/3 times 1 minus e raised to 3x raised to negative 1 plus c. So this is our final answer for this problem. And if you want to check that, you can try to differentiate it, and you should be getting the same expression as this one. Because if you try to differentiate this, then you can just have 2/3, copy it. Pwede nyo copyhin yung 2/3, and then multiply natin itong exponent itself nung ating function. So that will be -1, quantity 1 minus e raised to 3x, and then raised to yung buong quantity minus 2 kasi nagdi-differentiate tayo. And then, of course, the derivative of what's inside. So that will be negative e raised to 3x times positive 3. So with that being said, yung negative maka-cancel out, and then we're left out with this 2 e raised to 3x divided by 1 minus e raised to 3x quantity squared dx. Okay. Now for this problem, I had to incorporate the parentheses and some brackets just to emphasize that I'm talking about the 3x, the cosine of 3x and the sine of 2x, because in your handout, I think it's not specified, although you can just um, think of it as a common sense that it's literally taking the cosine of the inside function. But anyway, so let's deal with this problem. Now, what do you think is the inside function here? So what you have to do is try to differentiate functions that are inside the parentheses, or it could be inside the radical sign, so whichever is applicable. And then if you look at the other function, if it is the derivative of that, then that will be the inside function. So if you try to do this for this one, the derivative of this certain function here would be something like 2 cosine of x times negative sine of x, and then of course this plus cosine of 3x times 3. So that is the derivative of this first supposed the inside function. Now ito namang pangalawa, if you try to differentiate this, this will become 3 sine 3x. So you can write that, so that will be 3 sine, I'll be writing it here now. So 3 sine 3x, okay, should be negative, and then minus 2, I mean cosine 2x times 2. Okay, so with this expression, what do you think is the inside function? You might be thinking, oh, there is no inside function because the derivative of this one here, I'm talking about the function inside radical sign, is not doesn't look like this one, and of course the derivative of this one is not exactly the function that is inside the radical sign. So basically, you might be saying na wala ditong inside function. But the thing here is that the inside function here is this one, which means that this expression here is the derivative, which should be something like this. But you might be thinking, oh sir, it doesn't look the same because as you can see here, I do have 3 cosine 3x, but how about this negative sine 2x? Remember your trigonometry, we could say that this expression, negative 2 cosine x sine x, is simply equal to exactly negative sine 2x. So that means that this is our inside function, and this is the exact derivative of that inside function. So with that being said, the antiderivative of this function should be something like you take the antiderivative of our f of g of x, which is this cosine squared x plus sine 3x raised to 1/2. So with this, the derivative would be something like cosine squared x plus sine of 3x, and then we raise this to 1/2 plus 1, which is 3/2, and then we divide this by 3/2, which gives us 2/3 at the numerator. Okay, so you add the constant of integration. So this is the final answer for this problem. You can check that. So if you try to differentiate this, so you multiply this with the derivative of this expression, so that will be cancelled out, and now we're left with cosine squared x plus sine 3x raised to 1/2, which is literally this square root of cosine squared x plus sine 3x, and then you multiply this with the derivative of what's inside, so that will be 2 cosine x sine x, that's negative, so that becomes negative sine 2x, and then you add the derivative of sine 3x, which is actually 3 cosine 3x. Okay, so this pattern recognition is not limited to by simply taking the derivative and then that's all. You should also try to simplify the derivative that you've already found. Maybe it's kind of hidden in this derivative and you're just something like not really seeing that, if that's the case. So this is the second part of that basic integration procedure, when you have to at least do something like a little modification of your answer. Pero hindi naman siya sobrang complicated. It's just that you should be knowledgeable about the concepts as well. I mean, not the concept, but the rules of trigonometry. And of course, yung mga basic identities natin sa trigo. Hindi naman tayo mag-include dito ng sobrang complicated na, rules. Okay. So let's proceed with, I think that's the last example for pattern recognition. So I hope mas nagagets nyo siya. And by the way, wag kayong mag-alala kung hindi kayo, di nyo masundan itong pattern recognition kasi this is supposed to be done mentally. Now, if you're not capable of doing that for now, I think you'll be able to do that when we come to change of variables, because this one is, there's a formal rewriting of UDU, which is the basic foundation of pattern recognition. So don't worry about it. So this is the last one for your change of pattern recognition. So we have the integral of 3 raised to 2x and then divided by ln 3 and then plus 2x cubed square root of x to the fourth minus 7. Okay, so this expression is something like two terms. It has two terms. We can directly separate these two into 3 raised to 2x all over ln 3 times and then this one. Okay, so let's interchange. I'll be rewriting the integral using this one, yellow one. So ang gagawin natin sa unang term is that we will separate the first term here, which has a constant, so that is 1 over ln 3. So that is 1, the natural logarithm of 3. And then we multiply this with the derivative of 3 raised to 2x dx, which gives us the direct or fitting integrand of this expression, that is actually 3 raised to 2x. And in differentiation, this is supposed to be ln of the base, times ln of the base, and of course multiplied by the derivative of the expression or the exponent. So we'll be trying to inverse that. We'll try to inverse that procedure. So instead of multiplying this to ln 3, we will be dividing this by ln 3, so that is 1 over ln 3. And then of course, instead of multiplying this again by 2, we will be dividing this by 2, so that will be times 1/2. Okay, and then that's it for our first term. Now about the second term. Now the second term, as you can see it from here, the inside expression, the radical sign is the inside function, because the derivative of x to the fourth is actually 4x cubed, but in this case it's 2x cubed. So what we'll have to do here is to rewrite this in terms of we can rewrite this in terms of the exact derivative of this x to the fourth, so that will be 4x cubed and then the square root of x to the fourth minus 7. But since this is just 2x cubed and this one is 4, so we have to incorporate something like 1/2 here in front of it and then do the integration procedure. So in this way, I can just rewrite this term, this term only. So we can just rewrite this in terms of 1/2 the integral of 4x cubed square root of x to the fourth minus 7 dx. Okay. So with this, I can now proceed with integration procedures. So we add this 1/2 times the integral of this expression, which is actually x to the fourth minus 7 raised to 3/2, and then divided by 3/2, which gives us a multiplier of 2/3. Okay, and then you add c. Now, if you want to simplify this further, we can do that. So our final expression would be something like 3 raised to 2x divided by 2 ln squared 3, and then plus, I think this becomes 1/3, and then x to the fourth minus 7 raised to 3/2, and then we add the constant of integration. So this is your final answer. Now you might be thinking, how did this happen? So the first one here, yung ating ln 3 times ln 3, so you'll be putting the square or the exponent on the natural logarithm symbol. Okay, so it is above this n. Now you can also rewrite this in terms of something like ln 3 and then squared. You can do that, but of course it shouldn't be done something like this. It's incorrect. Okay, so you just have to do it something like the first one, this one, or you can express that in terms of this expression. And of course, for this one, I just perform the integration to I mean the power rule of integration. So that's it. If you wanted to check this one, you can just what you have to do here is to simply plug it out, this 1 over 2 ln squared 3 in differentiation. So let us just do it quickly here. So you can perform that in a way that you separate 1 over 2 ln squared 3 in the solution, and then I think I'm running out of space, so let's make this smaller. So you can do something like 1 over 2 ln squared 3, and then you multiply this with the derivative of 3 raised to 2x, which becomes 3 raised to 2x, copy mo lang yan, and then ln 3. Of course, that's the ln of the base, and then you multiply it with the derivative of the exponent, which is 2. So this one cancels out. So one of the ln 3 here cancels out, and then the 2 here cancels out. That's why we're left out with this expression. And then, of course, for the next one, the derivative of this expression becomes 1/3 times 3 halves, and then x to the fourth minus 7 raised to 3 halves minus 1 becomes 1 half, which gives us the square root of x to the fourth minus 7, and then you multiply this with the derivative of x to the fourth, so that is 4x cubed, which makes perfect sense because we can cancel out 3 here, and then this leaves this 4x cubed to 2x cubed only. So this gives us your original expression. Okay, so I hope you've understood that pattern recognition, although it's a little bit fast, but it's just basic integration procedures. And later on, I'll be discussing about the change of variables. So if you're not able to follow through this pattern recognition, then I hope you do well in this change of variables, because we're trying to assign variables that can replace the one that is written, so that it's a lot easier to integrate. Okay, so thank you, and I'll see you in the next video. Bye.